Okay. I'm trying a new platform here, so I'm not sure um, if this is actually working. If anybody joins in, if you could just send me a message through the live chat or an email letting me know that this is working. I need to dim this a little bit, so stand by a second here. Here we go. Is that a little better? I don't know. Here we go. Okay. All right, looks like we're good. Again, for those of you who, okay, Ira, perfect. I should have done a test run with this. I didn't realize that YouTube changed its platform, its video platform. So, but it looks like everything's working. So perfect. Okay. Okay. So tonight I'm gonna try to go through as many problems as I can. At least one of each. I should take up about an hour doing this. And if you have any specific questions as I go through this that you want me to cover, then just put them in the live chat box, and I'll make sure that I get to them. All right, so let's start right at the beginning. We'll get right into this, and we'll start with 1. Let's do 1C. All right, let's make sure everything looks good. Yeah, okay. I have the window open because I love to hear the crickets, so hopefully that's not a distraction. Yes, definitely, Kim. We're definitely going to do that. Okay, so 1C is asking you to find f of negative x. Now, you have to remember that this is a function, meaning that that you're being asked to take some kind of input and put it into this working machine and get a result, okay? So that working machine, I need to know what that machine is. It's f of x equals x squared minus 3x plus 5, okay? So there was a lot of confusion with this, especially with the x plus h problem, which we'll get to, but think of it more like this. F of the box means that you take wherever there's a variable, it's like there's a box, okay? I mean, you don't even need this, honestly. Don't even worry about this. Everywhere you see the variable x is a place for you to input some kind of value, okay? Over here, they're asking you to input a negative x. So you're literally going to fill those boxes with a negative x. And it's good to put them in parentheses. Okay? Negative x squared, that's a negative times a negative, so that would be a positive. Negative times a negative is also a positive. And this is our final result. You can't combine anything. All right? So that would be our function. Now, I kind of really want to jump down to 3, but let me not do that. Let's just pretend this is still our function, our machine, right? If I asked you to find f of x plus h, x plus h is the piece that they want you to put into the box, okay? It has nothing to do really with that x, nothing. It's not like you tag on an h. So we're literally going to plug in an x plus h inside the box. X plus h squared minus 3 times x plus h plus 5. And now you just have to be really careful with your expansion here. X plus h times x plus h, right? That's what x plus h squared means. So don't distribute that power. This is not a power thing. This is x squared plus xh plus another xh plus h squared. And then if we simplify, it's x squared plus 2xh, right? 2 of them, plus h squared. So that was all just from this. And now we have to bring down the negative 3x, negative 3h. Don't forget to distribute that negative twice. And then plus 5. Okay, so f of x plus h, it turns out to be a pretty long line of terms. Okay. Yes, we can do domain and range and polynomial with a radical. Polynomial with a radical? I think you mean like a function with a radical, maybe. Polynomials. Okay, yeah, we'll do polynomial stuff. All right. So number 2 is a composition of functions. So what I'll do is I'll give you maybe another problem like that. So this is like number 2. Let's say f of x is x minus 3, and g of x is x squared plus 1. All right, so you have 2 functions. Composition is putting one inside the other. Is that light in the way? Or, okay, I guess we can deal. I'll just write it lower. So you can be asked to put the x function into the g function or the g function into the x function. It just depends on how it's written. So let's find g of f of, let's do -3. Okay, you start with the inner function first. That's f of -3. So you're literally going to take the f function, you're going to substitute a -3 in place of the box, right? The variable. So f of -3 is the same as doing -3 in the box and then -3, which is -6. Okay, I just realized I don't even know how to, oh, okay. Thinking of all these other features, I don't even remember where they are on here. Okay, but I found it. Okay, moving on. So that's -6. All right, now we take -6 and we plug it into the g function. So we have g of -6. That's -6 squared plus 1, which is 36 plus 1, which is 37. Okay, so you work on the inside and out. You might also see this same exact thing written like G, and it looks like a little O of F, something like that with a -3. It means exactly the same thing. Hi, Brooke. Yes, I see your question. Okay, we can do that too. All right, let's take a look at problem 3, the difference quotient. You do not have to memorize this for the exam, so you'll be given it if it's on there. And the only thing you have to do is apply it. So the difference quotient is this. And you need to simplify this for some particular function, right? You have to have a function that you're going to be working with. This is, I don't know if you guys remember, this is actually related to slope. Okay, so it's you finding the slope of some function at some location. So you need a function, right? Like, what am I finding the slope of? So the function that you're given in this particular problem is, I keep writing this really high, sorry, 3x squared minus x. Okay, remember that's like 3 box squared minus box. And that box is where you put information in so that you can get information out. Okay, so we have 2 things that we need to put into this. We need to put in an x plus h, and then an x. So I like to use brackets to keep it organized. This is going to be for the x plus h part, and then, this will be for the x part. Okay, now this is always the easy part because you're putting x in place of the box. That's exactly what was there. So we can do that part first. Now the x plus h, that's the part that everybody has trouble with, right? They think they have to just add h. That's not what you're doing. They forget about the rest of the function, right? They just get so lost in the squared part that they forget that there's more to the function. So I would suggest doing that over in a separate area. We're going to find f of x plus h. So I'm going to put it here and here. Okay. Now we just did the expansion for x plus h. So I'm going to skip ahead here and just write down x squared plus 2xh plus h squared, and then minus x minus h. I distributed that negative. Ebony, right now I'm covering, I think if I caught you on time, I'm covering the difference quotient. This is number 3. Oh, Melissa, yeah, you got it. Thanks. How to get 2xh? When you do that expansion, I wish I could rewind. X plus h times x plus h. When you do all the distribution or foiling, you get x squared, right? You get xh, and then you get another xh. Even though it's hx, the order doesn't matter because multiplication, I can't talk tonight. Multiplication is commutative. So, all right, and then we've got h squared. So these guys right in here, that's where we get 2xh from. All right. Okay, so I'm going to distribute that 3. And I get 3x squared plus 6xh plus 3h squared minus x minus h. And all of that has to go in this set of brackets. 3h squared minus x minus h. All right. So, okay, good. Now all of that again, right? This is getting annoying. Plus h plus 3h squared minus x minus h. Okay, now distribute and distribute. Minus 3x squared plus x. Okay, now this is where you're going to have the cancellation of terms. If you don't get a cancellation, then something's wrong. So let's see, not black. Let's do red. All right, negative 3x squared and 3x squared. Negative x and x. And that's it. Okay, at least it was something. So all of the terms that are left over should have an h in it, which they do. That means that every single one of these can have an h drop out. So the final result will be 6x plus 3h minus 1. Essentially what you're doing is dividing each one by h, or you can factor out an h. And then the h's cancel. Okay? So that is your answer. Oops. Okay, that one is just kind of long and annoying, but all right. Okay, domain and range. So domain is the set of x's, right? Let's write this down. Domain is the set of all x values that work inside of a function. There's no problems. Domain is all the working x values. Okay. I think that, yeah, she usually wants you to have them written in interval notation. So we usually go from the smallest to the greatest, or biggest, whatever you want to say. The range is all the working, or we can say all the corresponding y values that all those x values go to. So it's the set of y values. And for these, we also go from the smallest to the greatest. And by that, we go from bottom to the top. Okay, this we go from left to right, that kind of thing. Okay, so let's see here. Let me maybe give you a function that we can find the domain and range of. Or actually, we should do a picture, and then we should do an actual function. Okay. So let me do, I don't know if you guys had any specific graph that you had a question on, but all right, give me 1 second. Hold on. I gotta take care of something real quick. All right. I just have to go run and do something really fast. I want to leave you guys though with a problem that you're gonna find the domain and range of. So let me just sketch it real quick though before I leave you. Okay, so let's do I'm trying to give you guys a different different kind of example than the ones in the graph. Okay, this one's a little tricky, but let's try it. Yeah. Melissa, don't worry about completing the square. You don't need it for the exam. Quadratic functions, yeah, we'll look at those. When you say quadratic functions, do you mean like like sketching them maybe? No, there's no sketching. Just maybe finding the coordinates of the vertex, maybe that. Synthetic division, you don't need synthetic division. Do you? Well, you can have a choice. You can either use synthetic division or long division. Okay. All right, let me just step out and take care of something really quick. Try to do this problem, okay? Domain and range. Now remember, domain goes from left to right, okay? And the range goes from the lowest to the highest. So left to right, low to high. Okay, and try to write this in interval notation. All right. I wish there was a pause button on this or something. I don't know. It's a miracle I can even do this. All right, I'll be right back. Okay. Sorry, guys. All right, so let's see. Some of you are putting answers. I like it. Okay, yes, we can do that also, Ira. Okay, so here are the answers. So the domain, if you go from left to right, on the left, it's an open circle. So it would start at parentheses -3. It goes and goes and goes. And even though there's some like, oh, sorry, that was supposed to be on 1. Even though there's a open and closed circle and they jump, it continues, right? It goes up here. And then it travels, 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 travels. And all of a sudden at 2, there's nothing. So we've got to stop this at 2. And then we're going to make a union and go from 2 to 3. Now 3 is included, so that would be a bracket. So some of you are close. Jose, you were kind of close. You just have to consider that 2 is not part of it. And then Kim, -1 is part of it because you have an open and a closed circle. So -1 is accounted for. If it was a closed circle, would there? Yeah, there would be a bracket. Okay. Now the range is the lowest to the highest. So the lowest, oh my, I'm so sorry. When I do it from this angle, it looks really great, but then head on, it's not. So that's supposed to be a 1 down here to match over there. So the lowest would be at 1, which is not included here, but it is there. So this would be 1. And then it goes up, 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 up till 2, which is included. And then there's nothing in here, and then just 3. So we would union that with a curly bracket 3 because it's only one number. -1 to 2 is not included because, well, it is included. Wait. Oh, it doesn't break at -1 because right here, right, this x value, this is not included. So that's why we have a parenthesis. Then included, 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 right? Everything matches. All of a sudden we get to -1. And even though there's a hole there, there's a closed circle here. So it has a match. It has something to go to. And then up here, we're good, we're good, we're good, we're good, we're good. All of a sudden at 2, there's nowhere to go to. And that's why we have to end it there and make a break. Okay? That was a little tricky. But does that kind of make sense now? Okay. All right, so now for domain, you'll also have to be able to do it from a function. You won't need to do the range, just the domain. Let's change colors here. Getting bored of blue. Okay, can we see that? Yeah, I guess it's okay. We've got, let's say, square root x minus 1. Ooh, okay. So this is a radical, and you cannot have negatives underneath a radical, okay? So it's okay to have a square root of 0. It's okay to have a square root of any positive number, just not a square root of a negative. So x minus 1, not x, don't think about x. X minus 1 just can't turn out to be a negative. So if it's not negative, it's positive, so greater than 0, or it's equal to 0. Solving this algebraically, it means that x can be anything greater than or equal to 1. So you'll probably have to write it in interval notation, or maybe you'll get extra credit for that. What you might want to do is put this on a number line. So greater than or equal to. and then go from there as far as the interval. So 1 is included, that would be a bracket, and then it goes all the way to infinity. Okay, so this would be the interval notation for the domain. All right, let's try another one. And if I'm going too fast, don't forget you guys can go back and like pause the video and that kind of thing. Let's do rad x plus 3 over 5x. Okay, give you a second to think about this. Oh dear. All right, so twofold problem here, not only a radical, but also a fraction. So with a fraction, we know that the denominator can't be a 0. Kim, these are called rational functions. Okay. The denominator can't be 0. That means that 5x cannot turn out to be a 0. If we solve for x, divide both sides by 5, divide by 5, so x can't be 0. All right, that's not going to be part of the domain. 0 cannot be part of the domain. The other problem is that we've got this radical. Now it's in the numerator, which means that x plus 3 could equal 0, so that's okay. But it can't be negative, so it has to be positive, which means that it has to be greater than 0. Okay? If we solve, we get that x is greater than negative 3. Now, if we put these together on a number line, we have negative 3, then 0. So it has to be greater than negative 3. It's not including. So open circle. Can't be 0. And then we continue. All right. In interval notation, this would be open bracket, negative 3, all the way to 0, open bracket. Then a union, stepping right over 0 and going to infinity. Okay. All right. Let's see. We're already 30 minutes in. Time flies, my oh my. I am going to do, let me see. Okay, I thought you were asking me a different question, Brooke. Okay, it looks like you guys really want polynomials in trig, and that would make sense because we really haven't talked about that much in recitation. So I'm going to jump down to, I'll do number 14. Now, for this midterm, okay, keep in mind that this course is separate from the ground course. So if you have friends that are in the ground course, don't talk to them. No, I was kidding. But really, don't talk to them about this course because we're on a separate level, okay? We're taking a different exam, so make sure you're in the right classroom that night. Right now, there's a different person that's going to be in there, but I'm going to actually try to get in there myself. But where was I going with that? Oh, yeah. So we have a different exam, and what they're doing is separate from us, okay? So we are not allowing a reference sheet, and we are also telling you what you need to know and not know. So You don't need to know the difference quotient. It will be given to you. I mean, you need to know sine, cosine, tangent, like SOHCAHTOA, opposite, and hypotenuse. But for most of you, you've already done this in high school. So it's just more like review. You do need to know the chart. And what I mean is you need to know your reference angles, like 30, 45, and 60, and how to find the sine of 30 and that kind of thing, I think. Or maybe not, actually. Actually, I don't think you even need to do that. Well, maybe. Okay, I need to look at the second page there. Anyway, yeah, sine of 30. Well, sine of 30 is 1/2. I forgot to read through here. Can you do number 13? 13? Yeah, we could do 13. So we should do 13 first, and then we'll do 14. So yes, Kim, always set the denominator equal to 0 for the rational functions. Radians. Radicans? Radians. Okay. Number 13. Let's do this one. Given that h of x equals f of g of x, decompose this, okay? So basically, g of x was some function and it was tucked inside f of x. They want you to indicate what do you think was tucked into what? I mean, just looking at it, the outside function looks like a cubed root thing, right? So, I mean, that's one type of function. Then I also see the inside. I see this. So this is something, this is something. This was put inside of this. So this piece is probably the g of x. I could let this be g of x. And when we put this in here, so I need to have a spot for it to go in, it looks just like this. So g of x was put into f of x. This will be f of x. This will be g of x. You're basically saying, okay, what was put into what? All right. Yeah, don't worry, Ebony. Okay. All right. Number 14. Find the 5th degree polynomial. Okay, so you were told it's 5th degree. And remember, that indicates to you how many roots there will be. There will be 5 roots. So it has, or zeros, same thing. X equals 3, 5, -4, -1. Okay, so right away I'm like, okay, 1, 2, 3, 4. That's only 4 of them. It's supposed to be 5. And 2 zeros at x equals 8. Okay, now I'm confused. Oh, because it's a double. So multiplicity 2. Wait, I am confused. Multiplicity 2. That should be 1, 2, 3, 4, 5, 6. Yeah, that's supposed to be 6th degree polynomial. Did anybody else pick up on that? That should be a 6th degree polynomial. That was a typo. Okay, so if there's multiplicity 2, we still count that as, I mean, it's a double of the same thing, but we still count that as 2 roots. So that's 1, 2, 3, 4, 5, 6. This is a 6th degree polynomial. So I'm going to start it off as writing factors. So if 3 is the root, then x minus 3 is the factor. If 5 is the root, then I have x minus 5. Then x plus 4, x plus 1, And then for 8, it gets squared because of multiplicity 2. Now, the only other thing here is that P of 0 is 40. P of 0 is 40. This is your x. This is your y. That means when I plug 0 into this function, the output is 40. Now, I don't know if that's going to happen if I plug 0 in. Let's check. So 0 minus 3, 0 minus 5, 0 plus 4, 0 plus 1, 0 minus 8 squared. Ugh, it's definitely not going to be 40. It's going to be a lot bigger. This is already 15, and then 15 times 4 times 64. Yeah, they're definitely not. This is 60. So what we need to bring in is a k value. And that k value is going to help turn this into 40. Now, we technically do not have a calculator, so I'm going to try to do my best to do this without a calculator. Yeah, Rachel, you're right. It's in the, there you go. You guys are good. Okay. So I'm going to solve for k, which means I'm going to divide by 60 times 64, whatever that is. So k is 40 over 60 times 64. Okay, now watch how I'm going to simplify this. 40 and 60, I can knock off the zeros. And then 4 divided by 6, that's 2/3. And then 2 goes into 64 once, and then 32 times. Look at that. So 32 times 3 is 96. So 1 over 96, that's our k. And that is not what I'm seeing here. Did I do something wrong? I really don't want to pull out the calculator. I feel like that would make me cheat. That's like making me a cheater. 15 times 4, 60. I can't see what she wrote here on the end, but it almost looks like a 42. All right, did anybody else get this? Let's check. I'm pulling out the calculator, folks. We got 15 times 4 times 64, which is a ridiculous number, but let's see. Yeah, it's 1 over 96. Okay, so that whole problem was just messed up. Okay, so there's the correct k, and putting this together, we need to bring that k into here. So this is our final answer, except let's throw in that 1 over 96. Okay, so this is the correct solution for problem 14. The quiz problem from today, yeah, I have that. You could look at that. All right, let's see, what time is it? All right. Okay, let me erase this. We can look at problem 17 that involves the quadratics. I think a couple of you asked me about quadratics. I think this is what you're asking me. Find the coordinates of the vertex. Okay, so let's do a different one that's not on here. Find coordinates of the vertex, okay? So the vertex sits on the axis of symmetry. Rachel, to answer your question, it doesn't matter because it's all being multiplied together. So beginning and middle, it doesn't matter. Oh, there you go. Okay, so the vertex sits on the axis of symmetry right here. So that x value is always going to be the axis of symmetry formula that we use, negative b over 2a. Okay, so over here, this is a, this is b, and this is c. Okay, so using this little piece to find the x coordinate of the vertex, we have negative b over 2 times our a, which is positive 3/4. Okay, so that's our x. And now to get y, it's good old-fashioned substitution. Okay, so I'm going to substitute 3/4, okay, into the function. All right, let's make way for this. Okay, so here I go. Okay, so we have to square this first. That's going to be 2 times 9/16 minus, this is like a multiplication of fractions, so 9/4, and then plus 1. Multiplying fractions, but I can do 2 and 16, so that'll be 9/8 minus 9/4 plus 1. And then I'm going to get common denominators everywhere of 8. So times 2 is 18 over 8. And then I can do 8 over 8. So 9 minus 18 is negative 9, plus 8 is negative 1. And then we keep that denominator. So the y coordinate is negative 1/8. And that would be the vertex for this problem. Okay. All right. Let's see. Number 20. Oh yeah, given the ordered pair, find the 6 trig function. Sure, we could do that. Put this here. Okay, now getting into the trig, there was a problem on WebAssign that somebody showed me, and it involved degrees and minutes. I don't know if any of you saw that. First of all, that problem wasn't supposed to make its way into the homework assignments, and it did. But that, first of all, you will never be tested on. You need a graphing calculator for that. You can put it into your graphing calculator. If you don't have one, you can use Desmos, or you could just take the hit from the problem by not doing it, or guess. Okay, so you need a calculator. It even says to round your answer to a couple places or something. So I'll show you real quick on a graphing calculator where to find that. Okay. So Kim, yes, it's always negative b over 2a. Okay. Okay. It looks like you guys are good. Yeah, I'm going through the review sheet. Well, some of them. Some of them I'm just making up just to give you additional practice. All right, but number 20. Given the ordered pair -1, 0, find the 6 trig functions. Okay, so our 6 trig functions are sine of the angle. That's just theta. It doesn't matter. You can make it an A. Cosine, tangent, and then the reciprocal of sine is cosecant. Reciprocal is secant, and then cotangent. Okay, so if you guys remember from high school, SOHCAHTOA, opposite over hypotenuse, adjacent over hypotenuse, and then opposite over adjacent. So depending on where the angle is, let's say this is the angle. This would be opposite, okay? The side opposite to the right angle, this is always hypotenuse. And then the side next to the angle is adjacent. All right. Now, if it gives you that ordered pair, that is actually, you can't draw a triangle with that. So -1, 0, -1, 0 is right on the axis. This is 0 degrees, 90 degrees, 180 degrees. So we're actually talking about 180 degrees. So for 180 degrees, this right here is cosine, and this right here is sine. Okay. I don't know if she talks about that in the videos yet, but yeah, you do have to know the reciprocals. I'm just reading through some of your comments. Yeah, Brooke, the one with the fire truck, that one was ridiculous. Don't worry about that. Okay, so anyway, for this, the sine is the y value, so it'll be 0. Cosine is -1. Tangent is equal to sine over cosine, okay? Just keep that in mind. You do have to know that. Sine over cosine. So if I'm doing 0 over -1, right? 0 over -1, that's just going to be 0. Now, cosecant is the reciprocal. That means that whatever sine is, you throw it in the denominator. So that would be 1 over 0. But we can't have a 0 in the denominator, so it's undefined. This one is going to be 1 over -1, which is -1. This is going to be 1 over 0, which is undefined. Okay? Let's look at the conversion from radians to degrees and degrees to radians. How do I know that that's sine and cosine? Well, there's a very long answer to that, but there's a proof for that. How do I say this? Let's do this. If I draw a triangle and this is the angle, right? Here's a point up here on, this is part of a circle actually. This distance right here is distance, we can say X, and this is distance Y, okay? The coordinates of this point are going to be however far X is and however high up Y is. So if this circle, I mean, depending on what the radius is, I don't know what the radius is, but you can use whatever you have here and say, okay, the sine of the angle right? This angle right here is opposite over hypotenuse. So opposite is y, hypotenuse is r, okay? If the radius is 1, then sine just turns out to be the y value, which is exactly what I was alluding to. Same thing for cosine, except it would be adjacent over hypotenuse. And if radius is 1, then cosine is just the x-coordinate. Yes, ouch. So y is sine and cosine is x, exactly. Okay. All right. So let's see here. About 10 or 15 minutes left. Let's do converting from radians to degrees. I don't know, do you guys want me to do the ones that are on here? Or do you want me to just give you different ones? I mean, you have the answers there. The cosecant confuses you? Well, cosecant is just going to be like, so sine goes with cosecant, right? I always think that like, because they have opposite letters, they go together. And cosine goes with secant, opposite letters, right? So sine of an angle is opposite over hypotenuse. Its reciprocal, the cosecant, is going to be hypotenuse over opposite. So it literally just flips it. Okay. Okay, so I guess we'll do, let me just give you guys some random. Convert 2 pi over 3 radians to degrees. And then convert 140 degrees to radians. I'll give you guys a minute to do that. I need chopstick desperately. Okay. Can you give us the hardest ones? Well, okay. I could change this to like 7. That's like really annoying though. I don't even think we'll do that. Yeah, let's not. We'll just keep it like that. These are good enough. All right, let me go grab my chopstick before I panic. Okay, all right. Let's see how you guys did. This one, we would multiply by, if I'm going to degrees, you can do 180 over pi. A little shortcut that I was showing today in recitation was that you can just substitute in a 180 for pi. And then you don't have to multiply 2 and 180. You can do 3 into 180, which is 60. So that would equal 120 degrees. And that's the answer for that one. Good job, Kim. And then converting 140 to radians, we were going to multiply by pi over 180. So you can knock out the zeros and you can get 14 over 18. So 14 pi over 18. And then don't forget to reduce. So yeah, 7/9. Good job. I love when I'm not by myself doing these problems. I mean, of course I'll do it, but okay. Problem from the homework. Let me just point this out really quick. Let me pull this up. Okay, so don't worry about this for the test, okay? Do not worry about this for the test. But for those of you who want to get the credit on the homework, this was like 54 degrees, and then 54 degrees, 18 seconds. And then this was 12.5. Okay, they wanted to know how tall this was. So if this is your angle, they're looking for this, right? This is opposite. This is hypotenuse. So the only trig function that uses opposite and hypotenuse is sine. So the sine of the angle, which is 54 degrees, 18 seconds, is equal to opposite, so I'll call this x, over hypotenuse. And then you would cross multiply. So you could throw that over 1. Then you have x equals 12.5 times the sine of 54 degrees, 18 seconds. Okay, you're going to put this all in your calculator. So again, you need a graphing calculator. And where's mine? Okay. Let me see if I can even find this on here. I think if you go to, shows you how much I use this button, like never. When you don't know where to go, just go to the catalog. Why can't I find it? This is ridiculous. Wait. Do you guys know what I'm talking about? It actually says like degree and then it says seconds. Oh man, where is this? Ah, found it. Okay. So you'll go into second, it says apps. So you're going to press second and then apps where it says angle. Okay, and I don't know if you guys can see this. There's an option for degrees and then an option for seconds. Okay, so you'll use that. Okay, so you go to second and then go to apps. Where is it? Okay, and when you type that in, you just do 12.5 times sine of, and then 54, use the degree, 18, use the little seconds, and then you'll get your answer. Okay, but don't worry about this problem. I know it was like, what in the world? But okay, did I answer everybody's question, I think? We did that, we did that. We did polynomials. I think we got everything, guys. right. So, oh, what was the answer? I don't know. I didn't type it in. I was going to leave that fun part for you guys. Let's see. Might as well do the whole thing, right? 12.5 times the sine of, make sure you're in degree mode, by the way, times the sine of 54 degrees and 18 seconds is 10.15. What did they want? 2 decimal places or something? 10.15. I think they just wanted it rounded to 2 decimal places. I can't see. I didn't take a picture of that part. Okay. What am I doing with the 18? I'm typing it in like this. Okay. Will there be radicals with the cosecant thing? Because on the homework you had to reduce it. There could be. Yeah, there could be. Like if you have something like this. Let's say here's the angle. Find the sine of theta. So for this, you would need opposite and hypotenuse. And we don't have opposite. We only have the hypotenuse. So first you need Pythagorean theorem to get it. 8 squared plus x squared equals 11 squared. 64 plus x squared equals 121. I was not sure on that one, yeah. And then x squared equals 121 minus 64. So this is 57, which means that x is radical 57. Okay, so opposite over hypotenuse would be radical 57 over 11. But if you're asked for the reciprocal, you would get 11 over rad 57, and then you have to rationalize it, which means that you have to multiply the numerator and denominator by rad 57. So that ends up being 11 rad 57 over 57. So that, yeah, that could come up. How to graph a function from an equation, like what we were doing in recitation today? Yeah, yes, Kim. It's just a formality. It's not like it's wrong to have a radical in the denominator. It's kind of like the negative exponent thing. It's not wrong to have negative exponents. Okay, so, all right, so the last thing we'll do is maybe a sketching of a polynomial, and then we'll call it a night. Oh dear, that's not good. Here. Okay, so when it's factored like this, it's easy for us to see what the roots are. We've got a -2, but multiplicity 2. This is multiplicity 2. That means a bounce. Then we've got -3. We've got 0. And we've got 1. Now, end behavior, remember, is determined by the leading exam. I saw your thing, Ebony. Will this be on the exam? This? Possibly. So the leading term is x times x times x times x, but there's a square here. So 1, 2, 3, 4, 5, x to the 5th. This is a positive odd, which means like this, okay? So we've got a bounce at -2. Somebody's driving very fast. Bounce, cut, and cut. Oh, graphing a parabola? I don't think you need to know that. Yeah, I don't think you need to be able to do that. I'm going to double check right now, but give me a second here. Yeah, you don't need to know that, Ira, so don't worry about it. All right, guys. Well, thank you for joining me tonight. I hope this was a help in some way or shape or form. Hopefully I'll see you guys. I'll be there, I hope, on Thursday night. Make sure, again, like I said, that you're in the right room. It's all posted on Blackboard. So if you're unsure for any reason, get there early, go there the day before, and make sure you know where you're going. And just bring your ID. Javits 109, yeah, the Javits building. First of all, in the dark, it looks like it's a different building. So, and it's far away and it's whatever. So make sure you know where you're going. All right, you're welcome. You're welcome. Not a problem. I should do one of these in the morning and see who the early birds are, which is not me. So probably not going to do this in the morning ever, but all right. All right, don't forget you can go and watch this again later. The link will always be available, okay? Don't forget to comment, to like, subscribe. No, it's kidding. Actually, not kidding, but no. All right, I'll see you guys soon, all right? Have a good night.